All right, what's up, everybody? I got Jason here. I'm going to show his video because it's pretty spot on. Response to William's live stream the other day ago, and I'm just going to play it. Here you go.
Why are we using accelerometers to show the effects of objects in free fall and show the effects of actual acceleration in any other direction, but when sitting on the ground, they're wrong. They're reading a constant velocity. Why the special pleading? I've been told over and over that there's no way the Earth could be moving up at a constant rate of acceleration because weight would continuously increase.
Don't agree when Jason says that constant acceleration would not increase the weight. I think he's wrong there. I've seen his demonstrations. It seems rather limited.
So the reason why I don't buy these experiments from the accelerating earthers, I think his name is Jason. Am I mistaken? I think it's the Rising Earth channel. In my opinion, these experiments that they're showing of acceleration, which is constant velocity, and the acceleration shows an increase in weight, in my opinion, those are parlor tricks. Why? I want to see an experiment of the claim, which is something accelerating 22 miles per hour every second, and show me the weight not increase. So for example, from 0 to 220 miles an hour in 10 seconds. Show me that experiment of something accelerating at from 0 to 220 miles per hour in 10 seconds without an increase in weight. Then I will give some merit to these experiments. Until I see that experiment, any other experiment, in my opinion, is just a parlor trick. The physics scale, yeah, when we're talking about relative speeds, like if something decelerates relative to a certain speed,
Should I read this really quick? Um, Predicting behavior. Scaling laws allow physicists to predict how a system will behave when its size or scale changes. Understanding complex systems. They can help simplify the analysis of complex systems by focusing on the relationships between key parameters. Um, Push and play. Physics. Scaling can refer to the relationships between physical quantities as an object's size or scale changes. Boom.
Your weight is simply the amount of force it takes to accelerate you, or your resistance to that force. Newton's second law of motion gives us the formula for how much force is required to accelerate an object. F equals ma. Force equals mass multiplied by acceleration. So the greater the mass of the object, or the quicker you try to accelerate the object, the greater the force that is required. Newton's third law states that, for every action there is an equal and opposite reaction. So the inertial resistance to the force required to accelerate you will be the exact same. Your weight is simply this same measure. It is the amount of force it takes to accelerate you. W equals ma. Weight equals mass multiplied by acceleration. Is it just the same as g-force? The numbers are expressed differently, but it's all the same F equals ma principle.
Let's see if these demonstrations correlate to Newton's second law. First, we have a mass of 600 grams. According to Newton, 600 grams multiplied by the acceleration of 9.8 meters per second squared equals 5.88 newtons of force. When I accelerate the mass, it goes up to 700 grams, or 6.86 newtons of force. It stays at that mass all the way up. If I put this into the formula and divide the 6.86 newtons of force by the original 600 grams of mass, I get a total acceleration of 11.43 meters per second squared. I must then subtract the original 9.8 meters per second squared from this 11.43 meters per second squared to get a 1.63 meters per second squared acceleration for the test. What this shows is that the demonstration had an added constant rate of acceleration of 1.63 meters per second squared.
Can you hear that beeping in the background?
I don't hear anything.
Okay, sorry. As we're working on putting whatever the smoke detectors up, and it's like beeping, and I don't know if you hear that.
Oh no, I don't hear it.
Okay,
But
hold
making the 600 gram mass increase to 700 grams. Well, you might be like me and think, oh, that's just math magics. Math can be made to describe anything. How can we test this? How can we see if this demonstration is accurate? How can we see if these numbers add up and line up? Well, we know that what the acceleration rate was 1.63 meters per second squared. We know the height of the test, which was 22 feet, which was the same as like 6.7 meters high. We can see how long it would take to accelerate something from 0 to 6.7 meters high at an acceleration rate of 1.63 meters per second squared. If we plug those numbers into the formula, we got 1.63 meters per second squared with a height of 6.7 meters. It should take approximately 2.24 seconds. Let's see what the test shows.
.27. Boom. I mean, and I guess it depends on exactly how.
When you start it, I mean, it'll
Yeah,
close like,
yeah, 2 seconds off, like whatever.
or, yeah, 2,000 off,
Oh yeah, my bad. Sorry, not
200 off, yeah.
It's just a parlor trick. It's just a parlor trick. It's just a parlor trick.
It's just a parlor trick. I love it. That's so funny, dude. I love it. Short and sweet, right to the point. He asked in the beginning, or somebody asked him in chat. Was that you who asked him? Can it be
Oh,
scaled?
I asked him if physics scaled in the chat whenever he kept saying he's got to be the 22 miles an hour per second to do the test to see if it does anything to the weight. And, I mean, sure, that could be done, but we could also just scale it down and see what it adds and see if everything correlates to F equals ma, which it does almost perfectly.
Yeah, yeah. No, I mean that's like it's
But
pretty.
you know what's not in that equation, F
Huh?
equals ma?
But
Constant velocity. It's acceleration. Force is mass times acceleration, not force times constant velocity, or force times or mass times speed. It's acceleration. It has to be an acceleration.
what would the numbers be if it were a constant? Do you
Uh,
know?
I don't know. I don't even know how you could calculate it. You would get nothing. You'd get because there's no resistance at a constant velocity with anything. So you 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 make anything travel at a constant velocity. And that's why accelerometers read 0 at constant velocity because there's no resistance.
Got it. Yeah, no, that makes sense. And like we would need a constantometer to read it
The
instead
constant
of
velociometer,
a constant velocity,
constantometer.
whatever it's called, or it would be called. Um, yeah, I think that's really well done and to the point. And I mean, yeah, I do you have anything else to say about this video? Should I start playing the other video?
No, you can play the other one. I think it summed it up pretty well. If they've got any critiques or questions about it, they can
It's not.
come talk to me.
Yeah, it's not like they're gonna, I mean, they could come in here and talk to us, but they're not going to. We've already invited them, and it seems like he made it pretty clear that he wants to just go back and forth with videos, which, fine by me, whatever. It would make it a lot shorter and quicker and to the point if you guys could just speak to each other one on one. But apparently, he doesn't want to do that. So, I
Yeah.
just did a mini compilation of his last stream and the one right before that. So that's what this video is that I'm about to play, and we'll just pause it as we go to talk about it. So if you do want to start talking about anything specifically, just start talking and I'll pause it and we can discuss. Okay?
Okay.
All right. So I think the very beginning was just him sitting.
So the reason why I don't buy these experiments from the accelerating earthers, I think his name is Jason. Am I mistaken? I
Yes,
think
we
it's
already saw this part.
what is it? The
Oh yeah, I didn't realize I put the
claiming
same
that
part
when
in
you
the
have an
video.
object, right,
Here's this part
and
right
you
here
release it
then.
into free fall, right, there's nothing decelerating it. So it's not decelerating down. So what happens is when you're holding it, it's accelerating with the earth and everything inside of it. So it's increasing its velocity. That's another thing that they're claiming. They're claiming acceleration as an increase in velocity. which again, at the end of the day, there's two different kinds of acceleration. There's acceleration linearly, which is increasing your velocity more and more and more and more. In other words, getting faster, 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 faster. And then there's also acceleration remaining at a constant velocity, which means you're not traveling in a straight line. So if you're traveling like in some kind of like circle,
That's not
rotation
velocity.
or some sort,
Yeah,
then you
that's
can
not
you
below.
can have a
Yeah,
That's what
traveling in
I,
a circle. Yeah, traveling in a circle is not a constant velocity. There may be a constant speed, but a velocity is a certain direction, and a rotation
same
is not.
direction. Yeah,
Right. To claim it's a constant velocity, which I mean, I understand what he's saying, so it's not like a big deal to
yeah,
me. It's just, but
semantics.
you know, semantics. But if you want to be correct, it's not a constant velocity. It would be a constant speed, constant rotational speed, but
Yeah.
not a velocity.
Yeah, and in this area of like what he's discussing, it would be really smart of him to use the proper terminology so that he doesn't make himself sound like he doesn't know what he's talking about. Because, yeah, he can't use the term velocity if he wants to sound like he knows what it
Right.
means.
And to get stuff
acceleration.
wrong, that's fine or whatever, but don't like put other people down for, you know,
Yeah,
whatever, or like saying people are dumb for thinking something different, you know?
yeah, yeah, exactly. Like I make mistakes all the time. Just a second ago, I said 2 seconds instead of, whatever milliseconds or whatever.
Right.
And that happens. Like people misspeak. Like he's used to saying his same script over and over. So saying velocity probably means the same thing as vector, and everything in his mind is like, whatever. Like I've interchanged those also before, on accident. Like so it happens, but at the same time, if you're gonna call everybody else dumb, you should really have your stuff on lock and not be, you know, so rude to people that actually do understand the argument and understand the physics. So keep playing
While
here.
remaining at a constant velocity. Why? Because there's a constant change in direction. But they're claiming that there's an acceleration that's increasing in its velocity. So they're going with the linear acceleration, right? So what they're claiming again is
Okay, so here, constant velocity describes an object's motion when its speed and direction remain constant over time. So, I mean, yeah, there's that, and then the acceleration increases when the net force acting on an object increases or the object's mass decreases. And what he's talking about is a centrifugal force is an apparent outward force that acts on an object. Oops, started didn't hold on, sorry, I forgot to push
There you
pause.
go.
So, and it goes by kind of fast. Here we go. An apparent outward force that acts on an object moving in a circle, which is what his force is he's talking about. That wouldn't be considered a constant acceleration, in my opinion. It's funny, I didn't even know this about it until I started like looking up definitions of centrifugal force, but they claim it's a fictitious force, meaning it only appears when viewed from a rotating frame of reference. In an inertial frame, there's no outward acceleration and objects move in a straight line. Explanation: imagine twirling a ball on a string. In the rotating frame of the string, the ball appears to be accelerating away. So, I actually did this in the past couple of days. I've been trying to recreate. I've seen a bunch of videos online of people putting water in a glass and attaching a string to it and spinning it, and they're like, "Oh, look, the water doesn't come out." But I haven't been able to find one where there's a video of the zoomed in, like of the actual water and what it does in the glass as it's spinning. So I've actually been gonna break away from this for 1 second and play this since it seems like a good time to play this. Um, so here's some of the footage from my observation. I'm not gonna call it an experiment because it wasn't an experiment. It's an observation. I tried to do some slow-mo so you could see. Um, it's hard because I'm spinning it myself, so I'm trying to keep my arm in, and um, basically the water does come up on the sides a lot. Um, there's also it might be a little easier to see what's happening with the pictures, the screenshots that I got of it. So, oops, here we go. So you can see the water coming up on the sides. It's not quite like the jury's still out on whether or not it actually would make concave. So just being honest with my findings, unlike what William does with his you'll see here in a minute he brings up his he calls it an experiment, but it wasn't. It was a demonstration, or not even a demonstration, because he never even showed us his findings. He just talked about it. But um
Oh yeah.
the elevator test that he's been talking about for, I want to say, at least 6 months he's been talking about it. And so apparently he finally did the elevator test, um, and it didn't show what he's been claiming it was going to show this whole time. So, I'm trying to be transparent here. I've been thinking for sure the water would be concave. In my, images there, it doesn't look fully concave, but it does look like the water comes up on the sides. If I can, do some more tests and get some better camera angles, or get like a more consistent, because the water kind of sloshes around because it's not like I'm doing it with my hand. It's not like a machine that's like even, while it's
Mhm.
spinning. So, if anybody knows of any videos, like I've been looking, but I haven't, it's only been a couple days that I've been really searching for those videos. So if anybody finds one, send it my way. It would be appreciated. But yeah, I'll keep playing this.
Comment that JC said that JC that he said that he recreated it and it showed the water level flat, which I'd like to see that. That's pretty awesome. It's
Yeah,
pretty awesome if it did.
yeah, exactly. That's what I was trying to see too. I mean, it definitely wasn't level flat when I did it, but it wasn't necessarily concave either. Like there was a couple of shots there of the stills that I got that looked like it could have been starting. Like maybe if I continually did it for longer and was super consistent with it, then maybe it would maybe it would start to go, but I think I need to do it for a longer period. Um,
Right, and I'm sure the speed of the rotation matters, and but typically, like with anything, I would think that being a rotation like that, it would only be like the most force would be directly in the center of that rotation. So um, any vector, you know, along anywhere away from the center point would be, converging vectors basically. So at some point, the water, in theory, would have to concave
yeah,
um, at any
that's
at a certain point.
That's what I thought too. And he asked what point would it do that? And I don't know if we have an answer for that. I don't. Do you know at what
No,
point,
it
like
just
at what
depends on,
speed?
yeah, if we knew like the dimensions like of the Earth and like how big everything was, how big the rotation was of the centrifuge, and the speed and everything. But you know, it's logically speaking, the water flat level wouldn't be flat at that point. Level wouldn't be horizontal. Level would be concave. And
Yeah,
so at some point it would have to go that way. In my thinking,
yeah,
I don't have any demonstration to back that up, but that's just how I would think. And just like the globe, they say level is flat, at a point, but then it starts to bend. It's just so big you can't see it bend, and
yeah,
uh, you know, so it's the same problem as a globe, in my opinion. And you
yeah.
kind of get away from level being horizontal, which
I
can be
agree.
demonstrated in any other way.
I agree. And it takes away from, now we're spinning. Now we're back to spinning again, Um,
Right.
like we are not spinning on an axis, but still, like it just, you know, I mean, I'm not gonna knock him if that, it's interesting. It made me look into
Yeah, and
centrifugal force that I never looked into before, so whatever, but
yeah, and definitely centrifugal forces will, cause, from what I've seen and read up on, they do cause the exact same forces of like pressure gradients and density gradients, like it would in a container accelerating in a single direction. Um, from what I've seen, I don't have my own demonstration of that though.
yeah, the ones that I've seen so far are like it's not like the cup water in a cup being spun on a string. It's like a flat, like you can see it makes it concave, but it's spinning. Like they would call that a straw man if I tried to use that, right? Like
Right,
the
like the horizontal spinning, like spinning of like a
y-
fish tank, what you see a lot
yeah, the
to
fish
show the
tank.
water curving up on the sides.
Yes, exactly. And I understand that that's not like the angle at which, they're talking
Right.
about, so I
At
chose
some
not
point,
to.
right. Yeah, and at some point, like those tests, um, if they were spun fast enough, in theory, they would, the vector would completely go to the side instead of the quote unquote gravity pulling the water down. If they were spun fast enough, at a constant rate, the vector would completely be, from the side instead of down or up
Yeah.
or whatever.
Yeah. Um, yeah, I think I talk about that a little bit more in like his drawing here in a second. I kind of readdress his what he imagined the centrifuge to look like with his little people standing the wrong way. But wait, would it even be called a vector, or would we have to call it something else at that point? Like
Well,
just
yeah, right. I mean, the vector is just basically anything perpendicular, to the force or or the direction of the force, and then the level would or horizontal would be perpendicular to that vector. So
got it.
yeah,
Okay. I know it can be confusing. I'm not trying to give him shit about using the wrong terms, but sometimes, but I'm also not, sitting here calling him a moron and all this stuff for using that. I'm just pointing out that
right. And
maybe, you know,
yeah, and if somebody corrects me, I don't have a problem. I don't if I say the wrong shit, I'm not trying to say I know everything or anything like that. I'm just
yeah, you're not
just
going to
trying
double
to
down or
describe.
admit when you're
Right.
wrong. And I've seen that firsthand, like for sure. So, all right, we'll keep playing the video. And then I don't remember what comes after this. Oh yeah, I did. I asked 'cause since Chat GTP or whatever seems to be like a big thing with these guys that they'll listen to chat but they won't listen to me. So I asked the Chat GTP, is centrifugal force considered a constant acceleration? Centrifugal force is often described as fictitious or pseudo force that appears when the observer is in a rotating reference frame. It is not a real force in the classical sense, rather it arises due to the inertia of an object moving in a circular path. In summary, centrifugal force is not considered a constant
But it is.
acceleration.
So again, it's a very weak, fictitious force. What's causing matter to decelerate, in my opinion.
So I just thought it was funny that he said that our thing was a fictitious force, but really the centrifugal force is actual is what, mainstream science defines
Does
as a
physics scale?
fictitious.
Yeah, when we're talking about relative speeds, like if something decelerates relative to a certain speed, then if something is moving way faster, then that deceleration is going to be way faster too, relative to the speed, which at the end of the day remains negligible. So again, the Earth's speed is key, to these experiments, to understanding what's going on. Like at the end of the day, I don't give a shit what the Earth is or what the speed is and none of that. Because again, I don't care whether Earth is accelerating up or not. At the end whether you believe it's accelerating, increasing its velocity, or a constant velocity, that doesn't matter. Ask her how fast are we moving up. It's irrelevant. That's irrelevant. We don't need to know the speed of the force to know that there's a force present. I'll give you an example. Force. We don't need to know the speed of the Earth. It's showing you when you read it. It's not going to overcome that. So again, the Earth's speed is key, to these experiments, to understanding what's going on, in my opinion. But again, in my opinion, if you're going to give merit to these experiments of the accelerating Earthers, then you're assuming that the Earth is moving at less than 1,000 miles an hour. You have to assume that the Earth is moving less than 1,000 miles an hour, and you can easily increase the effects by just adding 10 to 20 miles an hour to that speed. That's the only way you'll be able to add to it and see the effects of that addition of speed. Is if the Earth was moving at less than 1,000 miles an hour, which in my opinion, that's ridiculous. Because again, the Earth is massive. There's no way it's moving that slow. Relative to the Earth's size, that's very slow. That's almost like it's not even moving. You know what I'm saying? So again, that's again, I'm not dismissing accelerating Earth. I think sure, we could talk about it after, or again, if you have some experiments that are viable, and accelerating Earthers are fucking morons. Like Ken is a fucking idiot. Increasing velocity, and again, I'm not knocking it. The prime movers here. So where's your demonstration of weight gradient and vector at a constant if you so quick to call others morons? Weight gradient and vector at a constant. Oh, I'm gonna do a video. I just haven't had.
I'm just gonna pause it for a second because that made me laugh. So, just the way his face like changed, like he went from like ha ha ha, like talking shit to like reading and trying to understand what what Ken's actually asking and how he's gonna respond. And right after this, he goes into talking about his elevator experiment that he's gonna do. But before that, I just wanted to address what he just said, which, over and over he kept saying it doesn't matter. But then he said, like what was the very first thing he said that the weight is the most important thing. Like
Might as well.
learning what not the weight, but learning what the speed
Speed.
is the most important thing. So he said that in 1 second, but then says, "Oh, it doesn't matter, it doesn't matter, it doesn't matter." And I could have sworn that there's been multiple videos I've seen from him saying that, like making fun of accelerating, going, "Oh, it would just be going so fast, and it would just be going like so fast." And now it's not going fast enough, apparently. Like, you know, like
Right.
does it seem contradictory to me? But do you remember him saying like the opposite, and then now all of a sudden his view has changed almost like overnight, and now it's like, oh, it's going too slow?
Right. Yeah, I think. Well, he's what I've heard him say is he's been relating like the Earth velocity to like 1,000 miles an hour, and kind of saying everything is related to that. But then now he's saying that 1,000 miles per hour is way too slow, and then it would have to, in his opinion, like 500,000 miles an hour or way faster that it would have to be going.
Yeah, but before that,
While the same time saying that the accelerating Earth, there's the speed, would be have to be going so fast that it's ridiculous. But now he's claiming like some crazy speeds.
yeah, like before that, he was claiming, like before he actually did his elevator observation, it was, oh, you would just be going so fast, it's ridiculous. And then now, after doing the elevator demonstration and showing that he's wrong, now it's like he, had to figure out a way for, instead of just like listening to the thing and going, okay, this is what happened, and go, now he has to like change and like morph his numbers. So now his numbers have to be going so fast that it wouldn't show anything, instead of just entertaining the idea that it could be just constant acceleration. Like it's like, I don't know. It just sounds ridiculous to me. But I'll keep playing it
Right,
here.
and it doesn't.
Sorry.
Right, but it doesn't make sense. Like how they keep saying like a constant velocity, but it doesn't matter what velocity you're going at. There's never going to be a resistance. It's almost like in the definition of a constant velocity, meaning there's no net force. So, like, I don't know why they don't understand that. That's basically in the definition of being at a constant velocity is there's no net force acting on it. So there would be no extra resistance, so nothing would have weight at all at any constant velocity. Period. Like if they knew the laws of motion and understood that the only way to get any kind of force is with acceleration.
Yeah,
Um,
exactly. I
so they
agree.
keep trying to, and on top of that, and what I've been trying to get people to understand because of the light speed argument, and everybody saying that, well, if it's at a constant acceleration, at some point you'd be going, light speed, and that's not possible, and this and that, and well, they everything is related to a velocity. Well, velocity and speed doesn't mean anything if you don't have something to relate it to. And so, since we do not know what's outside this reference frame, all that can be measured is a force, and a force is proportional to acceleration. Period. Like there's no way that any velocity is going to give you any force.
Yeah,
So that's,
exactly.
I mean, absolute acceleration is the only thing that's real. Absolute velocity isn't a thing. That means nothing.
Yeah. No, exactly. It's like, who was it? I forget. I think it was his wife that was in the chat that kept saying, or no, he was saying it in the live stream, and then I had responded, but nobody wanted to respond to me. And I'm like, dude, you don't have anything to compare it to. Like, you're not outside of the frame, so how do you know? Like a speed is a speed on Earth, inside of the container, but like that means nothing if you can't go outside to,
Right.
like it doesn't. I don't know. It's
All
like,
yeah. All speed is relative. It's got to be related to something.
exactly.
Whereas acceleration can be measured by force. So, and that's what we can measure is the force.
Yeah. I remember now why I paused this in the beginning to read this really quick, so I'm just gonna rewind it for a quick second. So, oh, you can't see all of the comment, but his wife says, your topic of conversation isn't his focus, and he states why, but the name of the actual live stream is acceleration versus constant velocity. So when we went in the chat and started trying to discuss it, we kept being shut down, told that we're not talking about it anymore. He talked about it in the beginning and we weren't here for that, so too bad, rewind it and deal with it, whatever. So I just thought it was funny that everyone kept telling us that he's not talking about that now, but it's literally like the name of his live stream. So just made me laugh. Here's the part where he talks about the elevator, which is really funny because now we know that he did do it finally, and it didn't it didn't work out for him. So let's
So,
push play.
I just haven't had time. I need to go to like a building that has like 10 floors. And then my experiment is gonna be put a scale, stand on a scale.
And he also keeps saying experiment for everything, and I'm like, dude, it wouldn't be an experiment. It would just be an observation or a demonstration or like I don't know. I
Yeah, you
just
could say a test, but like to be like a scientific experiment, I mean, there's special things that have to be done and for that. So,
exactly
I mean, I don't mind calling it a test. I mean,
an
and it's
experiment.
almost semantic, but whatever.
It's also
Yeah, you get
you're
into
right.
like you get into like the Nathan Oakley like you know
Yeah.
super like strict definitions of science and experiment, but
Well, it's funny because he tries to do that though too. Like when he talked shit about the TFE and was like, "It's not even an experiment," and I'm like, "Oh, so you do know
right,
the difference
exactly.
between an experiment?" So he's allowed to use it, but if I bring it up, then like I'm some horrible shit starting bitch or whatever. But whatever. Anyways, I'm just gonna carry on um with this. Sorry, I keep stopping it.
And obviously I'm gonna weigh, whatever I weigh. And then as the scale accelerates up, obviously in the first second, after the first second, it's gonna remain at a constant to get to the 10th floor. I'm gonna show that the weight's gonna increase. Even if it's 1 pound, you're gonna see the weight increase. Even if it's slight, but I'm gonna be moving up at a constant, adding to the upwards vector. So, because elevators don't accelerate up to the 10th floor, they accelerate in the beginning. After the first second or 2 seconds after it reaches a constant velocity, they just remain at that constant velocity up until they reach the 10th floor. So, and that experiment will show an increase in weight at a constant velocity. So yeah, I can't wait. Accelerating again. You can put a scale on an elevator moving up at a constant, and the weight will increase. Even if you're moving at a constant, you don't have to be accelerating for the resistance to that force to be there. The resistance to matter. The reason why acceleration will cause a resistance to motion is because there is a resistance to motion, whether accelerating or constant. That's a fact. So you don't just have to be accelerating. You could also be reproduced using a constant force. And again, you can use that. I might recreate that one with an elevator moving up at a constant and to show that the weight will increase and remain at a constant. Because I did the experiment and I didn't see any change in the weight while it was moving up. But then it got me thinking, like, well, what if the Earth was traveling really, really fast? Because again, these accelerating Earthers are claiming 1.9 million per hour every day, increasing its velocity. So what if the Earth was moving at 500,000 miles an hour at least?
We have two claimed causes for your weight. We have constant motion, and we have acceleration. With the constant motion claim,
Shout out to Jimmy, by the way.
your weight
Shout
must
out
be
to Jimmy.
proportional.
Sorry, did you want to
I'll
add
put his.
anything?
No, I was just gonna say I did in my video. I did link Jimmy's video. I took part of it out of there. He does good descriptions of all this stuff. So
Yeah,
his channel's awesome.
I'll add a link to his channel also and your channel in this description too. So, all right, I'll keep playing. Oops.
To the velocity. This means that if you increase the velocity of the upwards motion, your weight must also increase. With the acceleration claim, your weight must be proportional to the rate of acceleration. This means that an increase in the rate of acceleration will increase your weight. For this vertical test, we will use an elevator and some weighing scales. The elevator is perfect because it first accelerates, then it travels at a constant velocity, then it decelerates. So we get to test everything in one go. The passenger weighs 164 pounds, but as the elevator accelerates upwards, the weight increases. Then the elevator settles at a constant velocity and the passenger's weight returns to its original weight of 164 pounds, proving that increasing the upwards velocity has no effect on weight. Then finally, the elevator decelerates, and the passenger's weight decreases. This simple test clearly shows that acceleration causes weight, and constant motion has no effect on weight whatsoever. Once again, this thoroughly debunks the constant motion claim.
On average. Because I did the experiment yeah, I didn't see any change in the weight while it was moving up, but then it got.
At least he admits, that he did the experiment or whatever demonstration, and
Right.
but the issue is that he's been talking about it for so long, and it's pretty like dishonest of him not to show because he recorded it. You know what I mean? Because he
Right.
went into it going, "This is what's gonna happen," and it didn't happen, and so he should at least still show the video to be like, "Hey, I did this," and it did, like with me and my water thing, it didn't necessarily show concave, but I did it and I'm gonna show it anyways. And, he'll probably see that and claim like, oh, look, it's proof of the tides or something. But anyways, we'll get into the tides in a minute. That's like a whole other topic. But did you want to add anything to the elevator thing before I move on?
Oh no, it was awesome test that he showed that the constant velocity added no weight, and the only time the weight did go up is when there was an acceleration.
Exactly.
So
So the proof is in the videos, in the demonstrations.
Got me thinking, like, well, what if the Earth was traveling really, really fast? Because again, these accelerating Earthers are claiming 1.9 million per hour every day, increasing its velocity. So what if the Earth was moving at 500,000 miles an hour at least, right?
So now it's okay to claim that it's moving like crazy fast speeds, right? Like before it was
right.
crazy for us to say that, but now all of a sudden because his elevator test fails, now he can entertain that.
Then
Right.
the velocity that you add from the elevator, it's pretty much negligible. I wouldn't expect to see a difference in weight. Adding 5 to 10 miles per
Except,
hour.
hold on, pause it
Yeah.
for a sec. He's like, it's at that point, like just that 5 or 10 miles an hour added to the velocity that it doesn't mean anything. But yet the acceleration from 0 to 5 miles an hour did show an increase.
Exactly.
So that's what's so crazy. Oh, 5 mile an hour, that's just not fast enough. But if you accelerate from 0 to 5 miles an hour, does that mean? Do you, what I don't? I think he doesn't understand that going from 0 to 5 miles an hour is an acceleration, but the velocity from 0 to 5 miles an hour is never above 5 miles an hour. So like you accelerate up to that point, but that's just how quickly you get to that velocity. So that doesn't mean that you're going fast. Like the velocity is faster in that little short time. So
Yeah,
why would it increase um, at a less velocity than the total with an acceleration? That's because the acceleration is what gives you the weight,
exactly.
not the velocity.
Exactly. Exactly. Um, no, I completely agree. I'll keep playing this and just yeah, if you want to start talking again, just start talking and I'll pause it. Whatever.
Upwards to the
Okay.
500,000 miles per hour, which again, that's at least, in my opinion, what the Earth is traveling. Could be traveling fast. In my opinion, these experiments that they're showing of acceleration versus constant velocity, and the acceleration shows an increase in weight, in my opinion, those are parlor tricks. Why? I want to see an experiment of the claim, which is something accelerating 22 miles per hour every second, and show me the weight not increase. So for example, from 0 to 220 miles an hour in 10 seconds. Show me that experiment. The physics scale, yeah, when we're talking
I
about
think I
relative
already
speed, here's another
played
thing.
this.
Even
Sorry,
if
I think it's like
acceleration
on
was
repeat.
required, right? Even if
But
acceleration was required,
Or it might have
in my
been from my
opinion, the
video.
Earth is not moving in a straight
yeah.
line. In my opinion, the Earth is moving on some kind of circular path. Again, the tides prove that.
So here's the one I drew where this is the way that it would, otherwise you would have the people all running
Of
into
that.
each other,
So person A holds.
going sideways. And like
Right.
see how his is drawn this way. All this person B would fall into A and would either go sideways or backwards or whatever way that they're standing would go up against this wall here. So I don't think they're really grasping what they're. And Dell also drew this incorrectly when so both of them don't understand the model that they're claiming and they haven't addressed it either. Like he didn't admit he was wrong and say, "Oh, I drew that wrong" or anything. Like for me, like it's okay to be wrong, but like admit when you're wrong and don't then double down on whatever it is that you're pushing, like that just seems really, intellectually dishonest in my opinion to not admit when you're wrong about something. talking about.
Right. It's kind of
Oh, was that you talking or the video?
no, I think it was a video.
Oh, sorry.
Weird though, also because um, they act like the Earth is moving up at a constant velocity for so long. That's what they've been pushing, been pushing, been pushing. There's no way it could be accelerating, except that all the effects we see show that it has to be accelerating. And so now they're switching back to basically an effect of an acceleration with a centrifuge. So they're conceding that it has to be, an acceleration versus a constant velocity, that they have to experience an acceleration. And now that's why they're flipping to this. And obviously they don't even have this right.
Yeah, and in okay, so this is the part where JC wrote about he spun a half empty water bottle in a circle and didn't observe any concavity at all. Which even that, like spinning a water bottle is like the equivalent of like the tests that we see over and over on YouTube, with the fish tanks where it does like show concavity, like you know what I mean? So um, I don't know. I mean, I do think that we should do more tests or whatever on this because I mean, yeah, like I haven't been able to find um like the one with the string spinning, like that. But anyways, um,
Right. Yeah, and I don't knock the
To satisfy
centrifuge in being that it could be a possible cause.
mhm.
Um, but for my logical reasoning, I don't see it working. I mean, it may be working at a tiny, tiny, tiny scale that where it wouldn't like same as the globe is like the globe is so big that water doesn't bend at a point, but it's just so big you don't see the water bend. That would be the same conclusion for me with the centrifuge that okay, maybe it's so big that you don't see the water bend at a point, but then once you go back bigger and bigger and bigger, at some point it's going to have to bend in my thinking.
Yeah,
And then at that point, water isn't horizontal anymore.
yeah.
Level
Well,
isn't horizontal.
Well, and all the research that I've done so far on it, it seems like the mainstream also came to that conclusion. Not to say that I always believe, obviously, what mainstream stuff says. So that's why I think it's good for us to do our own tests and observations. But this is a good video that I found that talks about it. So let's see what they say here.
this increasing centripetal force requirement, the fluid surface has to form a curved shape rather than a straight line. When the water volume rotates faster, each particle demands more centripetal force or more pressure difference across the particle. Therefore, the water surface curves more than in the previous case, or you feel like the water is going outward. It's better to avoid using centrifugal force in your scientific or engineering analyses because it's a pseudo-force used only in some special cases.
And then I did ask the ChatGPT, does water spinning in a centrifuge bend upward like concave or flat? Typically forms a concave shape. So, you know, just more chat GTP
Some
for
kind of
me.
circular path. Again, the tides prove that to me because there's a reorientation of water. Again, let me just go over this real quick for the ones that are new, So let me look this up. So again, the tides. The difference in height between the high tide and the low tide is called the tidal range. It's a horizontal movement of water, often accompanies the rising and falling of the tides. So again, that's what the tides are. So here we go. So the tidal range, the typical tidal range on the open ocean is about 1 meter, 3 feet. So on average, that's what it is. Closer to the coast, this range is much greater, and coastal tidal ranges vary globally and can differ anywhere from 0 over 16 meters, which is 52 feet. So again, the tidal range, it's a gradient. It's not a constant. So it's not the tidal range. So that shows me that the water's not being drained out and then poured back in, because that will give you an even, elevation of water, decrease and increase. That will give you an even, but it's not even. It's a deviation. It's a tidal range gradient that goes from 0 all the way up to 52 that humans have measured, right? So you have two options. If you believe in the globe Earth, this is what the tides look like. And again, if you understand the level Earth, then this is what it looks like. You only have two options. Literally, you only have two options.
So this also is very small-minded of him to say you literally only have two options. Like I think there's more options out there that he's not, like magnetism is an option. Magnetic poles, like we know salt water and different metals and water can pull water different ways. Like we know that lakes don't have don't have tides. And I looked it up. Apparently, somebody, I think it was Boomy in the chat, said that the Great Lakes have like a very small tide. And when I looked it up, it was like less than 5 millimeters or something like that. So, um, it just doesn't really make sense that, if it's is what he claims it is, then in my opinion, then like the water would on Earth would act in sync with each other, or somewhat in sync. And like I forgot to post these screenshots from the chat, but one man, his detector said that can be different from where you are. Tides are different all over the world. Boomy said that means it must be turning each 24 hours, but some places near to each other have very different high and low tides, which is very true if you've looked into any of this, if you're like into surfing or anything, like there's high and low tides that are like different from each other in close proximity. You don't have to believe in the map. Like, he says, oh, you can't go by what these maps say, but you can go by what surfers say, what people that study the tides and what they're doing and how they're acting with each other like regularly. And another thing, let's see. Boomy said, so how do you reconcile plumb and level with a not straight upward Earth? Which was a good question. And then
Hmm.
one man and his detector, the tides reason is very interesting, but we have to remember there's very large bodies of water, lakes that don't have tides movement only at a macro effect from strong winds. Which is true. Like when there's a crazy storm, you'll see some waves, but most of the time it's like pretty still. There's like little mini waves here and there. It depends on the wind really and but what else was there? I think that was all the screenshots from that. Did you want to add anything to that at the moment?
No, that was good. I mean, I think that like especially with the lakes and stuff, like whatever they do consider as water level differences, it doesn't correlate to tides or where the locations would be. If of course he says that we don't know what the map is and the layout of everything. So whatever, I guess that could be possible, but it doesn't seem to correlate much.
Yeah, it's a convenient excuse, like, oh, I can't trust the maps, so therefore I don't need to have any proof of my claims. Once again, I'm just going to make claims and not have anything to back it up with anything.
Yeah, and
Because
to
either the
say
water
that the deviation of water could only be because of the
Movement.
force or the movement of
Right.
the earth. you know that's just, yeah, that's pretty weak. I think
It,
there's many things that could cause that.
exactly. It's very close-minded for somebody who claims to be so open-minded about things. Like anybody that says there's only these two options, like hasn't been paying attention, in my opinion.
water is deviating or reorientating on level Earth, or it's just doing this weird fucking bulb shit on the globe, right? These are the only two options when it comes to the tides, when we're talking about the Earth and the water on Earth. So again, understanding that water cannot reorientate itself, that it reorientates relative to the direction of the vector, this shows me without a shadow of a doubt that the Earth is not moving in a straight line, because if it was moving in a straight line, then there wouldn't be a high tide and a low tide. The water will remain horizontal and not deviate from that. It would stay at that same orientation indefinitely. But we have a constant high tide and low tide. It's constant. It happens every 6 hours or so, right? We have four high tides and low tides a day. And they're constant. They never stop.
Okay, once again, another thing that he failed to look up. There's two high tides every day. So yeah, he's trying. Oh, this is a video of somebody hooking up a magnet to a battery. I was just trying to show that how magnetism could be. Like, I'm not trying to be like the motionless earthers and be
They
like,
want to
oh,
ignore the physics of
magnetism,
water.
magnetism is everything, but I do think it plays a role. I do think there's obviously, you know, I do believe in the ether. I do believe um, magnetic north and I do think that there's things that we don't know and we can't explain, and that's why we're here, right? We're trying to understand as best as we can with the tools that we have available to us, right?
And they just want to
Oh,
stick to that.
sorry, I was
Oh,
muted, but yeah, exactly.
it's
You're
linear
good.
acceleration and it's increasing its velocity into infinity. I'm just going base how I understand physics, and based, I'm just thinking about it logically, and these are the reasons to why I can't accept these experiments. Because again, these experiments assume that the Earth has to be moving at a slower rate than 1,000 miles an hour. You have to be assuming that, and that's why you don't see any displacement, at a constant by adding like 10 miles an hour to that, which, again, in my opinion, that's faulty reasoning, But again, people could believe whatever they want. At the end of the day, it's funny how these accelerating Earthers don't use the upwards motion of the Earth, whether you claim acceleration or constant velocity. It's funny how they don't focus on that as the main front of their main point, right? They still focus on the TFE. They still focus on bullshit fucking experiments, and don't even talk about this to other motionless flat earthers or globe earthers. They don't hammer down this fact that the Earth is pushing up. Again, whether you claim acceleration or constant velocity, that's something that could be talked about after we debunk the globe and the motionless flat Earth, in my opinion. So the fact that they're trying to drag this and to make it a debate and call me a shill because I don't agree with them that it's accelerating.
So once again, he fails to do any kind of research on his claims that he makes about us. He doesn't know either of us. We've been talking in public, about this, not super regularly, but in Geo's Earth Awakenings, sometimes there'd be 20 people in there with us and people online watching, and it's not nothing. You know what I mean? It's not. So anyways, I just took a couple of clips of us. This first one is from August 9th, 2004, and you can go back and listen to or if you really want to listen to the whole conversation, I could send it to you in the DMs. But let's see here. It's playing. Is it playing? Sorry. I don't know what's taking so long. I think it's like, oh, did I not push play?
We get it
Well,
all the time
why
around
don't we
here.
talk about the actual subject then instead of just naysaying it?
Which is what, Han? What are you talking about? When you say what?
About the upward moving Earth. Let's talk about that instead of naysaying it.
What you got proof for the upward moving
So
Earth then? Go
if
ahead
the
now.
Earth was
It's the
moving
only
upward,
thing that.
wouldn't the Earth be expanding in all directions? Wouldn't that be
Well,
logically consistent?
if it was a ball, yeah, that would be logical.
Okay, so if it's not a ball, you're saying it's just a plane, like a wafer that's moving upward.
Well, that's the only thing that's demonstrable with a
Well,
force acting something.
what about all the stars and celestial bodies? How come?
So yeah, that was
Like,
this one's from August 16th, 2024. Did you want to say anything? I know I only showed like a tiny little clip. There was a pretty long conversation. All of these are pretty long conversations. I wasn't about to post all of them, but I'm just trying to show examples of how this guy tries to claim that we don't talk about this with people and that we don't um, whatever. He doesn't know anything about us. Clearly hasn't been, paying attention to the community that he's supposedly all about. And this is from, 8 months ago or whatever. So anyways, I'll push play on this one.
I say this only because, like, it's almost like the only way we can change the direction of the density and the pressure relationship is with motion. And I know everybody hates on the upward rising Earth, but you can literally, like, if I accelerate or even constant motion, move something in a different direction, it uniformly changes that pressure gradient in the direction of acceleration or motion.
What do you mean?
Okay, so if I take, you've got the water bottle with the water on the bottom and the air's on the top. You drop it, and as it drops, the water stays at the bottom. The air bubbles go to the top. You can, if I take that water bottle sideways and apply
Sorry, I only did a clip of it, but
the pressure
August
gradient
23rd.
with directed towards the motion. Do you agree with that?
Yeah.
Okay, so we know that there's a pressure gradient on the Earth. What is a resistance to voltage? Pressure. What is a resistance to pressure or to voltage? Is pressure a resistance to voltage? If we have less pressure, can we get more voltage in the atmosphere?
If we have less pressure, can we get more voltage? That's your question?
Yeah, say, do you think there's a correlation with the gradient of the voltage on the Earth with pressure?
Yes, this is why they use vacuum tubes. There's more impedance in a vacuum.
Okay, so do you think that it's a possibility? I'm putting the cart way ahead of the horse. I've been trying to think of different scenarios for every different phenomena I see. So if the Earth was moving up, causing this pressure gradient because of the upward motion, causing the pressure gradient where it's higher pressure down low and lower pressure up high, and there's an electrical current in the air, where don't know where it's coming from, just if hypothetically, would that pressure gradient that the Earth rising cause the electrostatic gradient? Could it?
If your sky is
No.
a solid dome and everything's moving
Well,
together, then
it
it's
would be
not
a
causing a
container.
force on itself.
No, it definitely can. It does in a bottle of air.
Okay, look,
With
obviously this
motion.
is a foreign territory for me because I'm like trapping fellow flat earthers, but
No,
that's how you
no,
debate. That's how you
I'm
debate.
just right. I just want to hear all ideas. I'm just trying to figure shit out.
I just want to point out that like it's no ill intent when I'm trapping you guys. It's just debate, right? Like the way that you debate is you ask leading questions on purpose, right? Because like
Right.
where we're at now is we are incorporating the very primary causal agent I'm invoking, and it's going to have to be conceded in two different ways, and that is the change in the rate of fall and the downward electric current. So now we're going to go back to the fundamental first question, which is what exactly is it that occurs that requires the claim that the Earth is moving up? Because despite what anyone says to spin it, it is absolutely contrary to our empirical experience.
Well, all I'm saying is I want to demonstrate the electrostatics doing the same thing as motion.
Okay, but you can see what I'm saying, right? It's like
So funny how Witsit, like, he's trying in every way to like gish gallop and word salad his way out of it, but he doesn't have like, I don't know, it's just such funny to listen to. Back like listening to it at the time didn't do like I don't know, it's just different when you listen back on something, you know what I mean? Are you still there?
Yeah, sorry. I was on mute, but yeah, definitely. And I do recognize that I did state a lot of things wrong in those clips. Well, not necessarily wrong, but just my understanding at the time. So, but I do concede that like I did state some things wrong.
It's okay. I mean, we're learning. That's better than doubling down and being like, "No, I'm the smartest person here." But what exactly did you state that was wrong? It all sounded pretty like
I think when I correlated just motion being able to cause a pressure gradient, motion meaning like a constant velocity
okay.
causing a pressure gradient, which cannot happen, which I know now, which I did not at the beginning, more or less because I was following some people that did say that, and until I tested it for myself, that I didn't realize that the constant velocity will not cause a pressure gradient because it will not cause any resistance.
Got it. Okay. Yeah. No, that went over my head when I was listening to it just now. I didn't realize that was um, you know, whatever. I was just more paying attention to the way that Witsit was responding and how when I've heard him speak to Dell, because I don't think he's ever spoken to William, right? Have you ever heard him talk to William about
I
this?
know.
Yeah, I haven't. Um, but he seems a lot more relaxed and calm talking to you than he did to Dell. Obviously, that was a lot of yelling back and forth and craziness. But I enjoy listening to you go back and forth with these guys because you're respectful and because you're always trying to stick to the topic and not throw out insults or be in any way like disrespectful, which is why it was so surprising to me to have people on our own side attack you for doing demonstrations when like the stationary earthers have been, everyone's been talking so much shit about them from saying that they're the ones attacking and this and that, but we've gotten more hate from the upward earthers than we have from the stationary people. Like it's really crazy. I mean, not to say that I haven't gotten, some comments saying, "Oh, it's so stupid, I can't believe you believe that." But at least they weren't like it wasn't as insulting, and I don't know, it's more expected from them than from people that actually like really agree with us for the most part on most of this stuff. Um anyway, so I'll keep
the
Yeah,
way that
yeah,
this
I see.
argument has been.
yeah, that was the end of that one. Next one's October
That's what you're going to have to
15th.
show. And
Cool,
I
looking
don't
forward
think
to
you're
it.
going to be able to show it because, well, Physics tells us something different.
How could we show it even? Like that's what I'm trying to brainstorm with people is like, how can we prove that your side of things? Like if it's true, then how can we prove it? Is there a way to, or is it just not possible?
Well, I think it's the way the way the discussion or the thought process has been going about is wrong. Because when we see that, we look up on the ocean, we're sat on a beach, we're looking out, we see the water there, we see the air above it. That, to me, is quite clearly a demonstration of a fixed relationship. Now,
And
what
the
you've
clouds
done
are
is you
flat on
take,
the bottom. You ever notice
what,
that?
but I mean, that's besides the point.
You isolated gravity. So if you're going to make a positive claim of the Earth moving up, it's going to require that same burden. You're going to have to stop the Earth moving in order to prove it.
I agree.
Why?
But if there's also going to be a claim about electromagnetics causing stuff to do certain things, that should also be observable and proven also. So there's two claims that I think we should try and prove both. I'm not saying one does one and one does the other. Like we should be working together, not against each other. You know, we're not
I
Glovers
agree.
here.
I
Yeah,
agree. I agree. We should work together on this.
everything
And
is
what would be to obviously to prove the Earth moving one, we're going to have to stop the Earth from moving. So shouldn't we work on this electromagnetism thing? See if we
Yeah,
could do something like that.
exactly. That's what I was saying from the beginning was like, let's try to prove the electromagnetism thing. Let's try to get more involved in those sort of experiments. That's why I'm like, isn't that the point of us getting in these talks is to like try to do our own experiments or observations or whatever and like brainstorm on what we can come up with? Like, is there a way that we can demonstrate this or no?
Within the upward vector community.
So sorry, I'm just gonna pause it for a second, and elaborate a little bit on that because I still, I mean, that was what, 8 months ago, and still nobody from the ether side of things have, there was a few people in there that were talking about, I think like Brian Leake or whatever his name is, was talking about doing more Van de Graaff generator like tests or whatever. Um, and I mean, this is kind of it's funny because William does the same thing that Witsit does as far as, the attacking the ad homs and then, telling us that we need to prove his claim, like if you go back and listen to all the conversations with Witsit, like they don't want to do the demonstrations or try to prove the electrostatics. They just want to tell everybody that this is how it is, and it's the same thing with these guys, like with Dell and William. Like it's literally like they're part of the same club or something, the same clique. Like they want to tell us that we need to do the demonstration. Then we do a demonstration, and it's not good enough. It's not this. It's not that. Whatever. There's all these excuses and nonsense. But I just think it's funny how like I see so many similarities between the two of them. Um, but was there anything that you wanted to add to any of that?
No, that was good.
Quote unquote, there is a little bit of a a conflict, let's just call it, whether there is a constant acceleration or constant velocity. Now, again, I lean towards constant acceleration a little bit more. That makes more sense to me. Just by the fact that the 1g is equal to 9.8 meters square. That's fact enough. That's checkmate in my mind. The 1g is equal to 9.8 meters per square. So when you drop a phone and it goes to 0 g's, there is no downward acceleration and right? But then that motion, that force in itself is 9.8 meters per second squared. Full stop. You don't need to, I mean, like, okay, if there are experiments that William is going to be happy with, but that logic in itself is pretty sound in my mind, and that debunks the whole constant velocity thing in my mind, but if people are not convinced by that, that's fine. That's fine. But they cannot be in the position of constant velocity because they have not proven constant velocity. So I think it's fair to be in the position that we don't know whether it's constant velocity and constant acceleration, which I kind of put myself in a little bit more. I'm not going to just jump onto constant acceleration because that's, I think, a little bit foolhardy, because there could be other factors that I'm not really considering, whatever. But it makes more sense that there's constant acceleration. Now, of course, we're intelligent enough to say, well, if it's constant acceleration of 9.8 meters per second squared, then it goes to ludicrous speed in a day, a week, a month, a year. We're going light years, and we may very well be. Again, if it goes to warp 9, warp 20, warp million, warp infinity, so be it. If that's the truth, that's the truth. Who gives a fuck? You know, that I didn't build this reality, God did, and God has infinite powers to do whatever He wants to do with this reality. All I can say is that if that is what I observe, then that is what I observe. It goes to we're going to reach plaid speed, and so be it. And just because it's inconceivable in my mind, that doesn't make it not true.
I agree with that 100%. Like, just because, it's so funny that William, before was like, oh, it couldn't be going that fast. It's way too fast. And then he does his elevator test, and now all of a sudden, like, oh, it's not going fast enough. It needs to be going even faster. Like, and now all of a sudden, it's like he can entertain it, Like, I don't know.
Don't you get it? So I'll leave it there. Again, William, Natalie, I have respect for you guys, Amanda, and everybody else. But I would appreciate some qualification, because I did send you an email, William, if you wanted to have a conversation. You never replied back, so it makes me think that you are not interested in having a conversation with me, and thus I have been reluctant to chat in your in your channel, and because I don't want to make you guys feel uncomfortable. That's one thing. And I'm not trying to make waves or be a thorn on anybody's side. But if you guys want to have, any of you guys want to have a genuine conversation about this, and we can leave it at agree to disagree. But obviously, if once ad homs start coming out, then I guess it can go both ways still too. But I'm never going to accuse you guys of wanting to create division within the community for asking questions. I think that's I don't think that's fair. I think everybody should be given a voice. And if people I will say, like, it's not my intention to create division, but I want to have a genuine conversation with
In my
people.
opinion, that nobody comes to us to have a conversation about this. But yet I see Z, Tzetetic Warrior, and Nachiketa, they get like 5 callers at once sometimes.
He sounds jealous. To me, that sounds like he's not, he's not. And this is what trips me out is like he's over here complaining for like half of the stream about why people aren't coming in. And you got somebody that wants to talk about it, that's doing demonstrations. That's like, hey, over here, please. And they're like, nope, fuck you. Like, you know what I mean? Like, I just don't, it makes no sense.
So it's kind of weird. Like,
Here's my opinion. My opinion on that would be you and Dale kind of nip the fluff and the BS and the right in the butt. And maybe they, Natch might let them go on whatever tangent they want to go on a little bit before bringing it back.
Right. I guess we don't entertain the bullshit. And I guess you could say they kind of do in a way.
Sure.
No, it's kind of weird, I guess, in my opinion, especially since Dale was the first one to bring this to the table. And, I was one of the ones right after, to represent this online, and to the public, and to actually do demonstrations as well, and it's weird that nobody joins these panels. I'm going to be having these panels more often again, and we'll see if people actually join. It's kind of weird.
Sounds bitter, man. So yeah, I don't know. I will see, I guess, if he does more of this last one that he did that was months ago, oh yeah, I forgot to say. So this is his YouTube doesn't have like an email on it. We tried to message him through Discord, and he was in my Discord originally before it got deleted or whatever. Was for community guidelines or something. I don't know, probably Vax posts or something got it deleted. But I just noticed, I'm like, oh, they're both 33 years old. How could so is Witsit? How convenient. There's so many similarities between the two, not only in the way that they demand just experiments or demonstrations from us, but also the way that they throw out ad homs, the way that they argue and everything about like I seriously feel like they're like friends in the background, like kind of like United Nations, like they're all feuding and like they hate each other on the screen, but then they're like all partying together during the holidays and stuff. And I don't know, that's just my own opinion about them. Um, but yeah, was there anything else that you wanted to discuss? Did I leave anything out? I don't know. It was a pretty long stream. He said a lot, but I didn't want to
Not
spend
that I
too
can
much time.
think of, and I covered it pretty well. Uh, I'm just ready. I just want somebody to tell me how exactly my test doesn't scale with knowns that we have, and that how it's a parlor trick and how it's inconclusive or insufficient. Um, the math completely works out, whereas I normally would never appeal to math. But whenever whenever there are things that are quantifiable and have been defined and quantified, and everything checks out, and you can test if they check out, it's pretty hard to argue against.
Yeah,
Now,
I agree.
that being said, shit in the sky that we have no way of knowing, and they just assign these different masses to these bodies in the sky, like they could somehow prove that's ridiculous. But things here on Earth that we can quantify and measure and test, then yeah, I think math is a great tool.
I agree, 100%. Work with what we got, what we have access to, what we ourselves can demonstrate, and um, you know, just yeah. Word. Well, thank you so much for chatting it up with me. I'm sure, if William wants to have a conversation, like, he knows how to contact you, so, and he knows how to contact Notch, and, shout out to him for being an honest person and looking into this and actually, um, you know, like not shunning us and talking down on us, like it's not like we're not used to it being flat earthers, but you don't expect it from within a community, you know. So it's yeah, I guess we'll see. But yeah, I appreciate it, and you have a good day, and you all have a good day, and peace.
Peace.